Hello, and welcome to Exponents Part 2. We have 3 more rules to cover, so let's go ahead and get started with that. Alright, rule number 5 is the power rule. Basically, what we have is we're going to have a quantity taken to a power. Anything can be inside these parentheses. We're going to start with the basic one of just x to the nth power. And what happens is we just multiply those two exponents together. It's a power to a power. We multiply to get that large number. We want the power. So, couple examples. We have a cubed quantity squared. This rule dictates that we just multiply those exponents, so it'll be a to the 6th power. Another one here, same exact thing. We multiply our two exponents to give us a negative 12. But remember, our final answer cannot have a negative exponent. So using our negative exponent rule in the last video, we need to put this term in the denominator and make that 12 positive. There was nothing else in this problem, so 1 is in the numerator. Two more rules. Number 6. We just had the power rule. Now we're going to expand that power. It is pretty much the exact same thing as the normal power rule. The only difference is inside the parentheses, we're going to have more than one thing, not just an x. We're also going to have a y. And the expanded power rule just basically says everything in parentheses gets that exponent. So, for example, this is an example of the expanded power rule. Both the x and the y are going to get that 2 power. So what this means is the x squared will get that exponent and the y will get that exponent. Now, this is when we're really starting to use multiple rules in one problem. So that was the expanded power rule. If you look at one part, now what I just underlined looks like the normal power rule, in which case we multiply those exponents together. So it's going to be x to the 4th. Same thing with our y, going to be y to the negative 2 power. Once again, we have a negative exponent. That can't happen. So the y is going to move to the denominator. Before we're done, we need to make sure that it's simplified all the way. We didn't have any coefficients, so that's really nice. We don't have to worry about those, but we check to make sure it's simplified as much as possible. You see every variable only one time, and all of our exponents are positive. Therefore, that's the answer. Horrible box. Let's try that again. Still kind of learning the system. There's our box. That's our answer. All right, and last but not least, rule number 7. Now we get the expanded quotient. Now, if you remember the quotient rule, it was that we were dividing terms that have the same base, and what would happen is we just subtract those exponents. Well, the expanded quotient rule is very, very similar. Basically, we're going to be dividing something. They could be of the same base, they could be different bases. It really doesn't matter. And what we're going to do is take it to a specific power. What this rule states is that both the numerator and the denominator get that exact same power. Now I'm going to erase this because I need lots of room for this example. This problem is going to use a lot of information. Now, there are two ways to do this. The expanded quotient rule means that everything in the parentheses is going to get that squared exponent. I think the easiest way is to first simplify everything in parentheses first. Don't even worry about that 2 that I just highlighted. So my next step, I'm just going to leave the parentheses and the squared and worry about stuff in between. First, going to worry about my coefficients. 4 divided by 10. That simplifies to 2/5. Now, I'm going to worry about my variable y. That's just the normal quotient rule, so I'm going to subtract those. And remember, since we're subtracting a -3, we're really adding. So it'll be 2y to the 5th divided by 5, and all of that is going to be squared. Now what happens here is every single thing is going to be squared. This coefficient will be squared, giving us an answer of 4. The 5 will be squared, giving us an answer of 25. And so will the y, which we learned from our power rule. We get to multiply those exponents together, so it'll be y to the 10th power. Before we box your answer, make sure that your coefficients are simplified, which they are, and we see every variable only once, and that exponents are all positive.